Hello everyone. In this video, we're going to see about A-star search algorithm, which is a search algorithm in the context of artificial intelligence. So let's dive into it. So in this video, we're going to split this video as 5 sections: introduction, heuristic search, and some key terms, and a solved example. We'll be working on a solved example, and then final conclusion. First, what is A-star search? It is a search algorithm in artificial intelligence. It's a pathfinding and graph traversal algorithm. It's a graph traversal algorithm. It's designed to find the shortest path from the start node to the goal node. So it will have a start node and a goal node. The key strength of A-star is that it combines the actual cost so far with an estimated cost to reach the goal. Just a search algorithm from start node to goal node, it will find the shortest path using heuristic. So what is heuristic? What is heuristic search? Heuristic search is a search strategy that uses an additional knowledge, which is a heuristic, to guide the search process more efficiently than uninformed search algorithms like a BFS or DFS. A heuristic is simply a rule of thumb, an estimate or extra information that helps the algorithm decide which path is more promising. Instead of blindly exploring all possible paths, heuristic search uses this estimate to focus on paths that are more likely to lead the goal faster. So, what is a heuristic? Heuristic is just simply a knowledge, or we can take this as a clue that guides the system to find the shortest path possible from a start to goal. Then, A-star search is also a heuristic search because it uses a heuristic. It combines two things, which is g of n and h of n. What is g of n? It is the actual cost from start to the current node. So what is h of n? H of n is a heuristic estimate of the cost from the current node to the goal. So what will be the formula to find that? F of n equals g of n plus h of n. The heuristic function h of n redirects the search towards the goal more intelligently. As we already seen, the heuristic function directs the search towards the goal more intelligently because it is a clue or a knowledge for find the shortest path. If h of n is well chosen and admissible, never overestimate the true cost. A-star is guaranteed to find the optimal path. Unlike uninformed searches, A-star uses heuristics to prioritize exploration, making it faster and more efficient in practice. It is more efficient in practice, and it also gives us the shortest path possible. A-star search algorithm. So we'll be seeing the algorithm first now. It might be a little harder, or might be not that easier, but when we solve the problem, it will become fine. So I'll first read the algorithm. Step 1, initialize the open list, initialize the closed list, put the starting node on the open list. You can leave it f at 0. Third, while the open list is not empty, find the node with least f on the open list, call it q. Pop q off the open list, generate q successors and set their parents to q. Fourth, for each successor, if successor is the goal, stop the search. Else, compute both g and h for successor. What is successor of g? Q dot g plus distance between successor and q. And what will be the h? Distance between goal to successor. So applying the same formula, f of n equal to g of n plus h of n. Here it's given as successor of f is equals to successor of g plus successor dot h. Both are same. If a node with the same position as successor is in the open list, which has a lower f than successor, skip this successor. If a node with the same position as successor is in the closed list, which has a lower f than successor, skip this successor. Otherwise, add the node to the open list. Then finally end the for loop. So now we are going to move to the solved example. So now we are considering this graph as an example. So in this graph, we can able to see the nodes, the A, B, C, D, E, G. This F, it's not mentioned, sorry for that. And the values, the number values that are written above the arrows are the value of G. Okay, and here these are H values. This is the basic understanding of the graph. So first we are going to sorry, the A is the starting node, and we have to traverse through all these nodes and to find the goal, which is G. We are using A star search algorithm for this particular graph. So step number 1, start. Open A. So this is A. The G value is 0, and f of A is 5, because see, the heuristic h of n is 5. For this A, the value of h is 5 and the G value is 0. So as per the formula, f of n is equal to G of n plus h of n. Value of G is 0 plus value of h is 5. So 0 plus 5 is 5. So here that is mentioned, the f of A value is 5 initially, and the child of the node A is B and C. Okay, so while expanding A, we will be getting, first we have to see B here. The value of G will be 1. It's mentioned here. The value of G is 1 and the heuristic value is 4. So 4 plus 1, which is 5. So f of B is 5 here. Remember, f of B is 5. And we are going to see the this value of C. So the value of G is 3, which is mentioned here, 3, and the value of H is 4. It is mentioned here. So 4 plus 3, which is 7. So the f of n of B is 5, f of n of C is 7, and among these two, which is smaller, f of B, which is 5. So the algorithm will consider or will expand the node B first. Now expanding node B, and the same is mentioned here too. See, f of B is 5 and f of C is 7. Now then we have to expand the B. While expanding B, we will be getting two nodes, D and E, and we have to apply the same rules. Now the G value of D, which is G of D, how to find it? We have to consider, or we have to add the G from the initial node to the current node. We already saw that, right? Saw that, right, in the presentation. The value of G is the additive value from the initial node to the current node. So the G of D will be 1 here, the 1 plus 3, which is 4. G of D is 4 and the heuristic value 3. 4 plus 3 is 7 for D. So f of D is 7, and we have to find the f of E. G of E will be 1 plus 1, 2, and the H value is 2. So 2 plus 2 equals 4, and the same mentioned here. F of D is 7 and f of E is 4. So among this, which is smaller? F of E, which is 4. Now we have to expand E, and we are getting this G. The value of G of n, which is G of G here, the G value will be 1 plus 1 plus 2. A to B 1, B to E 1, and E to G, which is 2. So 1 plus 2 plus 2 is 4, and the heuristic value of G is 0. So 4 plus 0, which is 4. The f of G value is 4, and G is the goal node we need. So goal is reached. So from this we have achieved reaching to the goal node with the shortest possible steps. So the path will be A to B, B to E, and E to G, and the total cost is 4. So this is the shortest path, and while seeing the graph, you may calculate the paths easily, and this is just for mere understanding. So while taking this path A, B, D, G, calculate the G values. 1 plus 3 plus 5, which is 5 plus 3 8, 8 plus 1 9. The path A to B, B to D, D to G is 9, and this path A to B, B to E, and E to G is 4, and the another A to C, C to this F that's not here, F, and to G is 3 plus 5 8, 8 plus 2 10. So 9, 4, 10. The minimum value is 4, that is the shortest path we got from A star search algorithm. So this A star search algorithm, using this algorithm, we will be achieving the shortest path possible for search in a graph. And now we are going to see some applications of A-star search algorithm. If there is any algorithm, there must be an application, right? So there are many applications of A-star search algorithm, but we will be going to see some of those. One, pathfinding in games. This algorithm is used in video games uh, to move characters or units from one point to another. This ensures realistic movement, avoiding obstacle while reaching the goal quickly. This is the very very mere example. And robotics and navigation, of course, helps robot plan efficient paths in unknown or partially known environments. This will be used in that line tracing robots and all. And then GPS and maps, of course, to ensure that the given path is shortest or the fastest route. And that network routing, artificial intelligence planning, puzzle solving, like 8 puzzles, 15 puzzles, Sudoku, that will be done with backtracking as well. Speech and NLP, robotic motion planning in AI research, and many fields. This A-star search algorithm is widely being used. It is one of the famous and most efficient search algorithms to ensure the shortest path. And here we come to the end of this video. I believe that this algorithm will be most familiar to you as of now. Thank you for watching this video. Thank you.